Today we're going to be talking about DNA replication. Remember, replicate means to make a copy. So here we have a copy of DNA plus a printing press. So if you want to think of it as like we're taking DNA, we're going to make a lot of the same copy, and we're going to get a whole bunch of copies of DNA. DNA replication. During replication, the DNA molecule is going to split into two halves. So we have the one original molecule, and we're going to make a copy of one strand, and we're going to have the duplicate strand, or the regular strand. So we're going to have the original, and then we're going to have the copy, which is the green. And when all is said and done, we're going to have two exact copies of the original molecule, and we will now have two molecules. Each half serves as a template or blueprint to make a new whole DNA molecule. When we make a new strand, we call it a daughter strand. So, for instance, this green strand is the daughter strand. That's the new one. Step 1. DNA helicase, an enzyme, is going to come and unzip the middle of the DNA molecule. So if you want to think of this as almost like a axe, and it's going to come and it's going to unzip, kind of like I'm going up or down with my zipper, and it's going to unzip the DNA molecule. So it's going to undo the hydrogen bonds that hold the nucleotides together, and I'm going to get my one strand here, and I'm going to get my one strand here. Step 2. New bases or letters are laid down according to the template on each side of the DNA. So A and T, C and G. So if I had an A on the original strand, on the new strand, the T nucleotide will match up with it. Remember, A always pairs with T, C always pairs with G. The job of the DNA polymerase is to add the nucleotides. So I think of like polymerase as like paste. So the polymerase is going to paste in the new letters or nucleotides. Step 3. Each new strand is zipped back. You now have two identical strands of DNA, each containing one piece of the old DNA and one piece of the new DNA. So here's my molecule as I first talked about. The original strand is here, and then I have the new strand that is interwound. So I have one double helix here. On my second molecule, I have the original strand that was unzipped, and now I have the copy strand, the daughter strand, and I have another molecule and another double helix. That's it.